The overall goal of this procedure is to introduce a real-time robotic mirror therapy system for functional recovery of hemiplegic arms.
This method can help answer key questions in translational neuro-rehab biomedical engineering research by showing that functional recovery of a hemiplegic arm with advanced occupational therapy is achievable. The main advantage of this robotic mirror therapy is that it can enhance proprioceptive input to the sensory cortex, which is very important in brain neuroplasticity for stroke patients.
Individuals new to this method may struggle, as it was complicated to develop the software protocol and assemble frames and motors.
We first had the idea for this method when we observed conventional mirror therapy, which was limited in that the hemiplegic arm was not actually moving.
Visual demonstration of this method is critical as the sensor settings, assembly, and setup for robotic mirror therapy are difficult to learn.
Begin by obtaining 3 Attitude and Heading Reference System, or AHRS sensors, and connect them to a computer one at a time with a USB connector. Use communication software to configure the general sensor settings on the computer. Set each sensor to RS-232 and select the COM port. Then, set the baud rate to 115,200 bits per second, data bits to 8, parity to none, stop bits to 1, and the flow control to